Integers are a set of numbers made up of positive and negative whole numbers, and they are given the symbol z. So, integers are used across the curriculum in STEM subjects and math. They are used in most subjects which deal with quantities. For solving integer problems, you can use number lines. So if I just draw a standard number line that most people will be comfortable with, it starts from 0 and it goes up to 5, and it goes up in differences of one whole number. So this is an integer number line because it contains only whole numbers, and what that means is that it does not contain fractions or decimals. So this number line that I'm going to draw below, which is going to go from 0 to 3, if I then am going up in halves, 0.5, 1, 1.5, 2, 2.5, this is not an integer number line because it contains fractions. So, looking at more complex number lines, 0 is not usually the starting point. Number lines can cover any range of numbers, but for integers, you could have the 0 somewhere in the middle, and you could deal with 1, 2, 3, 4, and 5, but you can also go back down to 0 to -1, -2, -3, -4, and -5. This is still an integer number line because it contains whole numbers, and despite the fact that they're negative, they are still whole numbers and they are still used in an integer number line. So this can have multiple applications. You could talk about this as temperature. So we could give this units of degrees Celsius. So we could say that 0 degrees Celsius is freezing point of water. And of course, as everyone knows, temperatures can vary below this or above this. And that is really just how you can understand using number lines. And we will come back to this when we move on to addition of integers and subtraction of integers. Hiya, so in this section I'm going to be looking at addition and subtraction of positive integers. So here we have 1 plus 1 and we know this equals 2. However, more complex problems can come along containing 2-digit or 3-digit and so on numbers. However, we treat these using a chimney sum, or you can do it in your head, but just for safety I always do a chimney sum. So say I'll pick out two random numbers. Say I had 63 and I had 25. So for this, if I'm going to be adding these, I just add in the addition symbol, and I will draw a line, and my solution will go underneath this line. So firstly, I deal with the first digit, the digit on the furthest right. So 3 plus 5 is equal to 8. Then moving on to the second digits, 6 plus by 2 is equal to 8. So the solution to 63 plus 25 is equal to 88. Then if we move on to further complex calculations with positive integers, we could have a look at something like 174 plus 49. So these numbers are pretty horrific, but we'll just go through them in the same system. So 4 plus 9. That is equal to 13. However, because there's only one digit here, we can only have one digit here. So if it is equal to 13, we'll have to put the small one down here and the big 3 here. So it's 13, but the 10 that is originally added to this 3 to form 13 has to be carried on to the next section. Then we just look at these numbers first. 7 plus by 4 is equal to 11. So that's the 11 up here plus by the 1 left over here. So that is equal to 12. And once again, we bring down the 1 here, we bring the 2 here. Finally, we've got this. So this is, we could say this is 0 because 49 is equal to 049, which is equal to 0049. It doesn't really matter how many zeros you add to the left. So 1 plus by 0 is equal to 1, with the carried over is equal to 2. So for our solution for this one, we have a solution of 223. So we can now move on to subtraction of positive integers. So subtraction is always feels more challenging, but if you just follow a system, you'll be able to get the solution to all of the problems. So we'll start off with some basic ones. So we could have 9 subtract 7. So what we can have is, if we take away 7 from 9, how many will we have left over? And we will have 2 left over. And a way of determining this, I always feel for negatives, it's quite good just to have a number line. If we have a basic number line from 1 to 10, so this is just using our skills from the last section. If you have 9 originally, and you're going to be subtracting 7, you will just go 1, 2, 3, 4, 5, 6, 7 to the left because it's subtraction, and we know it's 2. However, if you are going to be subtracting more complex problems, so with 2-digit numbers, you will need to use a chimney sum format, or you can do it in your head. It's just there's a greater margin for error if you do it in your head. So we can have 65 subtract, we could do 65 subtract 42. So this is it looks quite tricky, however we can break it down. So first, looking at the first digit, 5 subtracted by 2. 5 subtract 2, sorry. So if we've got 5 here, I'll have the tallies down here, and we're going to take away 2, so we're going to move to the left, it'll be 5, 1, 2, with a solution of 3. Nothing left over, so we don't need to bring anything along. And then for 6 and 4, that is 6. Take away 4, so we move 4 spaces along the left. 1, 2, 3, 4, that is 2. So and the solution for this problem is 23. And if I move on to a more complex problem, and this is just going to show the ease of using a number line. If I was to have 792 subtract 467, so this sum looks really tricky actually, but if you solve it in the same way, I might actually just draw a new number line just to keep the work clear and easy to follow. So for this, first it is 2 subtract 7. So this is awkward because, you know, 2 subtract 7 will form a negative number. However, you don't need to worry about that. What you do is you move up to this number on top and you move 1 digit along. So that's got 9. However, we can take numbers from this 9. So if you cross out the 9, you take 1 across, so this ends up being 12. and you bring this down to being an 8 because the 1's been taken away from this and added over there. So now it's just 12 subtracted 7. So 12 take away 7. If I extend this number line, 11 and 12, I can do 12 moving along 7 spaces. So I'll go 1, 2, 3, 4, 5, 6, 7. So that is equal to 5. For 8 subtracted by 6, once again, we can use the number line for that one. It's quite an easy calculation. 8 moving along 6 spaces to the left. 1, 2, 3, 4, 5, 6. So it's a solution of 2. For 7 taking away 4, that we can just solve that in the same way with the number line. So we need to move along 4 spaces to the left. So that's 1, 2, 3, 4, leaving 3. 325 as a solution for that problem. Hiya, in this section we're going to be looking at adding and subtracting with negatives. So negative integers can always be a wee bit of a pain, but if you learn how to tackle them, it isn't actually that tricky. So firstly we'll do when one integer is positive and one integer is negative for addition. So we have 6 plus negative 2. So this looks quite awkward. However, because we have this plus and this minus, the minus takes the priority over the plus. So it's essentially equal to 6 subtract 2, which as we know is equal to 4. However, you can use a number line for this. So you can use quite a few number lines actually, but I'll just show you some of the basic ones. So for this, we could start off at 6. 6 plus negative 2. So for addition, you'll usually move to the right. However, because there's a negative, you move to the left. So you move 2 to the left. So you go 1, 2, and it's 4, like the solution shows. However, what you could do is you could rewrite 6 plus by the negative 2 as negative 2 plus 6, because this 6 could just have a plus in front of it because it is a positive integer. So for that, if you just like following the rules and you don't want to flip it, you can just rewrite it this way. So you can have the negative 2 plus the 6, so you're moving to the right, 6 spaces, so that's 1, 2, 3, 4, 5, 6. Once again, you land on the 4. So that's how you can tackle those. However, for more complex problems where you've got two negative integers, you have to tackle it a wee bit differently. So say I had negative 4 plus by negative 3. So like we saw in this example above, sorry, let's put brackets around my negatives just to distinguish them. If you have a plus and a minus, that can usually just cross out the plus. So you can just have that as negative 4 take away 3. However, if that seems too confusing, you can just use a number line. Again, because it is just negative numbers, I'm going to put 0 on the far right, because for this number line, I'm doing it on the left hand side, it's the lowest value, and on the right hand side, it's the highest value. And just something just to note is that for negative numbers, 0 is the highest, and negative infinity is the lowest, if you understand. So that if I just go here, let's go negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. So I can just look at this as negative 4 plus negative 3. So because that's a negative, I'm going to move 3 spaces to the left. So 1, 2, 3, giving a solution. Sorry, you got to add the equal sign up there. Equaling -7. And what makes this a bit trickier is that you can't rewrite it. Well, you could rewrite it, but it's not really going to eliminate any difficulty, because if you were to rewrite that as -3 take away 4, you've got the exact same issue as before, because you've got a negative something being subtracted from a negative. But if you follow the number line, it should be pretty straightforward. Okay, so this is just a note to add that sometimes you can have positive integers and a negative integer can be added to that, and that will result in a negative integer being your solution. So you could have 4 minus 12. So for this, it looks pretty awkward because you know that your solution will be lower than 0 because 12 is greater than 4. However, you can just solve this using your number line once again. So for this, you can tackle either way, but let me just quickly write out my values. Oh, that's a bit. I can extend it onto this other bit of paper though. So for this, you could approach it as 4, the 4 up here, and you could do -12, meaning that it goes to the left. So that could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, giving me a solution of -8. Or you could have a look at it, rewriting it like we've done before, as -12 plus the 4, because the 4 is a positive integer. So you could have -12 plus 4. 1, 2, 3, 4, giving you once again the solution of -8. So that is just trickier parts of adding negatives. Hiya. So for more complex problems, there's a particular strategy you can use for calculating them. So say you had 215 and you're subtracting 325. So you know that this number is going to be lower than 0, but it can sometimes be a wee bit awkward doing it. So what I suggest doing is thinking about how much will be left over from this when this is subtracted from this, as it will be on the other end. I'm sorry, I know that's a bad explanation, but if you think about it, this is a 215, take away 325, and to reduce this to 0, you're essentially taking away 215 away from this, and then whatever's left here is negative. So for this, despite the fact you're always supposed to take this number away from this number, I would do 325 subtract 215. This isn't a final answer, but for 5 to subtract 5, that's equal to 0. For 2 subtract 1, that's equal to 1. For 3 subtract 2, that is also equal to 1. So you've got 110. So if you think about it, once this 215 is subtracted to bring it down to 0, there will be 110 left over. So that's 0 subtract 110 to give a final solution of -110. So if you try and just think about that, think it through that way, that's a good way of working with more complex numbers. Hiya. So for subtraction of negative integers, please look at an example problem like 4 take away -2. This can look quite awkward because we've never seen a negative next to a negative, but what I do is that I visualize almost that the signs collide and they just form a plus. So that becomes quite a simple equation that isn't as tricky. So it's just 4 plus 2, which is equal to 6. Sorry, put up the equal signs there. And you can use this for bigger numbers, it doesn't really matter, it's just based on whether that integer is positive or negative. So we could have like 926 to take away 243, negative 243, sorry, and you could look at that and you'd just be heartbroken because subtracting chimney sums are the worst. But no, they'll just those collide. So that's 96 plus 243, and then you can just bring that down like we've done before. 3 plus 6 is equal to 9, 2 plus 4 is equal to 6, and 9 plus 2 is equal to 11. And yet again, you can use your number line from moving along. So so just to summarise, just as a final bit for a number line, when you are adding, you move those spaces to the right. When you're subtracting, you move those spaces to the left. For adding positive integers, if you have x plus y, you can just write that as x plus y, giving you your solution here. If you are subtracting, you get x minus y. Remember, it needs to be x take away the y, whereas for this you could have the y over the x. It's not, doesn't really matter, but for this it needs to, because it's this taking away this. It's not just what's all together like when you're adding. And then for subtracting negatives or adding or subtracting, so for adding negatives, if you have x plus negative y, that is equal to x take away y. And if you have x take away negative y, that is just equal to x plus y. So not to confuse anyone with x plus y's, but that's just a way of summarising the basic rules that I've covered in this video. Thanks so much for watching.